Hello. How's everybody doing? All right. Welcome, welcome. Happy Thursday. Happy 3-day weekend. Yes. Yeah. Amanda's like, yes, I'm there. I'm needing that 3-day weekend. Let me tell you, I got to get caught up on grading. I'm getting better. It's getting closer. So every little bit helps. All right. So I'm going to share my screen. I just tell you a couple things about MCC that some of you know, some of you don't know, some of you haven't been on campus very much. Some of you on campus and maybe you're missing, I don't know if that's true, but I'm missing campus. We have a lot of fun things on campus that we can't experience right now, but we will eventually, right? We will get back there. Vaccinations seem to be going better in Arizona. You know, like we seem to be getting more doses. I just heard Maricopa County opened it to 65 and up now. So if any of you have grandparents, parents, relatives, friends who are in that age group, they should try to get an appointment, you know, because it is available. Yay! Bethel got her second vaccine last Saturday. And Bethel, did you have any side effects?
I did. So I had my arm hurt, like I cried every time I moved it. I got the chills and fatigue and a slight fever, but it went away like the next day.
Nice. Okay. Good. So I get mine second vaccine next Friday. Next Friday, like not the 12th, but the 19th. So the good news is I'm getting it on a Friday, right? So then I can just go to bed and be miserable for whatever, 12 hours or whatever it is. I could sleep for 12 hours. I'm pretty sure I could. It's a lie. I couldn't, but it's okay. Okay. So reminder, no class on Monday. Campus is closed for President's Day, but campus is closed anyway. So I don't know why that's a big surprise. Volunteering. I know that a lot of you volunteer in classrooms or your service learning or things like that. So I want to share with you MCC's civic engagement, which is right here. Any of you apply for this MCC service scholarship? that's available. The deadline is tomorrow. And if you're new to MCC, you might not have known about it, so you couldn't apply. If you're still on your journey at MCC, you could apply again. They'll do it again in the fall. You meet the first criteria, I'm sure, being enrolled in at least 6 credits for spring right now. Some of you may meet this, some of you may not. Complete 100 community service hours at a nonprofit or government agency during the 2020 calendar year. Now, 2020 was a little rougher to volunteer, right? So, but maybe you have those services. So if you do, submit your application. I'm just on the MCC Civic Engagement website. So, and you could link this in my slides. But some of you, if you looked at my announcements for this week, was anyone able to attend the human trafficking session yesterday? Might have been during our class. I can't even remember because I was telling my 257 students about it. Their civil action hour is Wednesdays from 12 to 1, so it's perfect time right during our class. But they were doing human trafficking awareness, and they were specifically talking about child sex trafficking, which is terrifying to me. So it's just nice that we have these programs going on and we have a lot of options. But if you're interested in service learning, you can do service learning. Even if your class isn't doing service learning, we have individual serving projects as well. So you just click on that serving link and you can get all the information you need. Okay. So the other thing I wanted to show you, the other thing I wanted to show you was some of you, like I said, have been on campus. Some of you have not. But we have over permanent public art exhibits created by MCC students and faculty as well as artists. Did you know that? And you can walk around and see any of these displays. So here's a map of campus and you can see where most of them are located. A lot of them are down on the south end of campus by the theater and those types of buildings, interior design and things like that. Some are also by the math. This one is inside where my office is, if I was ever in my office anymore. But Madeline Chowdhury is a math faculty here, and she did math in art and she did a lot of history. So it was fascinating. So, and then this was an installation that was put up not very long ago, 2017. And it was by a former student and math faculty, and then I believe a welding faculty here on campus. So amazing. But you can see how many of them there are. If you're interested in them, you can look at just the list. Some of you have probably seen some of these on campus and always wondered what they were about. So if that's you, you can click on them. But if you hopefully we'll get back on campus and then look for these places, because I think it's really cool that Mesa supports, you know, our artists that we have as well as faculty that are interested in these things. So I always wonder where there's really cool ones in the math building, and I don't even think they have them listed here. Like they have really cool ones inside the math building that were by interior design students. I don't even see them on here. They should add them. All right. But so anyway, that was just my little side note of, I think it's awesome, the things that we have at MCC. Today, we're going to change gears a little bit and talk about integers. Okay. Yeah. I love all the art that's at campus. Like it's amazing. They have so many cool things. So we're going to change gears and talk about integers. We're just going to barely scratch the surface and then we'll talk about them next week. Now, integers don't come up until 6th grade. So some of you won't really ever be exposed to that. But I told you yesterday that I had a 2nd grader doing negative numbers. And I was like, interesting. So don't count them out. And you still need to be knowledgeable about that. I do want you to try this warm up. Just do the first part right now and get it ready in the chat. Write an example of the commutative property of multiplication. Write an example of the commutative property of multiplication. So just little numbers, right? Symbols, whatever. And then Be prepared to explain why it shows the commutative property. Hopefully you can do this without looking up what the commutative property is. Yes? Okay, if you're wrong in the chat, who cares? Okay, so get it ready. I'll give you about 30 seconds. Don't hit enter yet. All right, we'll just do it. 3, 2, 1, go. All right, look through them. Very nice. So be sure that the commutative property shows that you can do any order of those factors and you still get the same result. And it should be multiplication. It should be, like, for example, I'm just looking at Michaela's 2 times 3 equals 3 times 2, or 5 times 4 equals 4 times 5. They did it algebraically. A times B equals B times A. Very nice. So excellent job. Be careful. A couple of you showed, like Madison on yours, you moved parentheses. That's the associative property. Okay. So that's the associative property. I can change grouping. And Karina, I'm not sure what you were showing on yours. 3 times 2.
I couldn't remember exactly what the property was, but I remembered when I learned it in school, it was like the family property. That's kind of what they called it. So I did like the multiples of 3.
Okay. Yeah. So make sure you get it now, right, Karina? That it's be 3 times 2 equals 2 times 3, or 6 times 9 equals 9 times 6, anything like that. You might be talking about fact families. I don't know. Is that what you were thinking of? Fact families?
I think like when I was learning the properties in school, they would call the commutative property the community or like the family property. I'm not sure why my teacher did that, but I think he was just trying to get us to remember.
Right. To learn that weird word, probably. Yeah. So some people, has anyone heard of fact families before? Yeah. So fact families, I can draw a little fact family. This really doesn't have anything to do with the commutative property, but a lot of teachers show it, and a lot of teachers show it in a little house like this sometimes. And they show something like the 3 numbers might be 3, 2, and 6. And they would say the fact family there would be 3 times 2 equals 6, 2 times 3 equals 6, 6 divided by 3 equals 2, and 6 divided by 2 equals 3. Apparently my house wasn't big enough. Sorry, we had to build an addition right there. So, but so that's a fact family for multiplication. And you could do a fact family for addition. You could use 3, 2, and 5, right? 3 plus 2 is 5. 2 plus 3 is 5. 5 minus 3 is 2. 5 minus 2 is 3, right? So that's really connecting addition and subtraction and multiplication and division. But for the commutative property, it is what we talked about yesterday, that turnaround property, right? Where the order of the factors does not matter. All right, before we get into integers and what are they, I'm going to give you a problem that I want you to think about. I don't know why that font is so small. I'm going to read it. I don't think I can make it bigger. Maybe I can. I'm not that smart right now. I don't know how to make it bigger. But anyway, I'll read it to you. So listen carefully. There's 18 people in a class. If every person shakes hands once with each person, how many handshakes will occur? So everybody understand the question. So by the way, this is post-COVID. Everybody's actually shaking hands again. It's okay. Okay. I didn't want to rewrite the problem. So there's 18 people in a class. If every person shakes hands once with each person, how many handshakes will occur? I'm going to give you about 3 minutes to think by yourself. Okay. Then I'm going to put you in some random groups, maybe, unless everybody has their number. If everybody has their number, I'll put you there. And then you guys can talk about, do we have any idea what we're doing? Are our answers the same? Are they different? You can use Poya's 4-step method. You don't have to write it all out. That just helps you think it through. Okay. So think about that for 3 minutes. I just started the timer. All right. So I know you might not have an answer, but that's your 3 minute of alone think time. Now I'm going to put you in your breakout rooms, chat with your teammates, and see if you're on the same page, if you're on a different page, what your plan is, all those kind of things. And you can call me in for help, but I want you to have been making some progress. There you go. Oh, you're
I was
muted.
connected on my phone, so I'm just trying to get back into my group with my computer now.
You're good. You're good. And I'm closing the rooms anyway, so no big
Oh,
deal.
okay, I'll just hang around here.
Yeah, hang around here. And then if we go back in the rooms, I'll just put you back in there. You're good.
Okay, thank you.
Yep. Did your group come up with an answer?
We were kind of in between two answers, and we were still trying to like work it out, talk it through. So
Okay, good. We'll see. All right, welcome back. I didn't get to visit all the rooms. I visited a couple rooms. Some groups have an answer. I think some groups are still on the fence if they have a final answer or if they are still debating between a couple answers. So, group 1, do you have an answer? You don't have to tell me your answer, but do you have an answer? Yes. And group 2, do you have an answer? Yes. Okay. Group 3, do you have an answer? Kind of. Okay. I appreciate your honesty. I like that. Group 4, do you have an answer?
Yes.
Okay. And Sydney, Michaela said yes, you have an answer. So Sydney, apparently Michaela has the answer. So you're good. Team 5, do you have an answer?
Yep.
Okay. Team 6, do you have an answer?
Yep.
Okay. And team 7, do you have an answer? Yes. Okay. And team 8, do you have an answer?
Maybe.
Kind of. Okay. Kind of. Okay. So teams that are unsure of their answer, can you just tell us your strategy that you were using? Like, were you drawing a picture? Were you trying to write an equation? What was your strategy you were using? So team 8, team 3-ish.
I can talk. So for us, we did area model because we figured 18 students, and if they're going to have to shake hands with everybody but themselves, it would be 17 students that they have to shake hands with. So we split it up into 9 and 9, and then 10 and 7, and then just figured out the area from there, and then added all those up together to get 306.
That's an interesting strategy, right? Yeah, we got 306 with theirs. And a lot of you were thinking the same thing. 18 times 17 because you can't shake your own hand, right? And Sunita put it in the chat. They did 18 times 18, but they also thought maybe 18 times 17. So those are good ideas. I like those ideas. Teams that have an answer, was that your strategy?
We tried that at first, but then we thought 18 times 18, and then we thought, oh, 18 times 17 or 17 times 17, but we realized that that was going to be a really big number. So we Brandon tried to draw a picture and we kind of visualized it, and then we realized that perhaps it's addition instead of multiplication. So we did 17 plus 16 plus 15 all the way down to 1 to get an answer of 153.
Okay. So, and I know another team did a picture. Evelyn, do you have your board still? Hold your board up so everybody can see it. Like right there. There you go.
It's a little different. I ended on 2 because the last 2 people will be shaking hands instead of one person by themselves. I don't know if I should have done 1. So me and my team didn't really get to that part, but I did 152. but that's my picture.
Okay, so I think what Evelyn's saying is she wasn't sure if she should have 152 or 153. Am I right, Evelyn? Is that what you were saying? Okay.
Yeah, that's what I was saying.
Any comments on that? Any groups, did you get 152 or 153, and why or why not?
So I didn't do the addition, but now thinking about it, it may have been better, but I did the multiplication one
Okay, show us your board.
where I did the area model where I multiplied instead of added. So 9 plus 9 for 18, and then 9 plus 9 on top for 18, and I just multiplied 81
Okay.
to get 324 handshakes, but I think that's a little too big now.
Oh, so now we have lots of answers. And
Yeah.
even Bethel says maybe hers is too big. Let's talk about the 18 times 18 versus 18 times 17. Which do you think it would be? Do you 18 by 18ers, do you count this as a handshake? Probably not. So 18 by 18's probably too big, right? But 18 times 17's, I think you're on the right track. I'm not saying your answer is correct, but I'm saying I think your idea sounds really awesome, right? So, and is there a way, if you were doing 18 times 17, let's pretend Vanessa and I are two of these people in the classroom. Does it count as a different handshake if I shake Vanessa's hand and Vanessa shakes my hand? Is that one handshake or two handshakes? That's one handshake. So if you did 18 times 17, do you think you might be double counting? Yeah. Okay. So let's go to Evelyn's strategy. Evelyn's saying the first person, person number 18, shakes 17 other hands, right? Then the next person shakes 16, then the next person shakes 15, and so on. Should she go down to 1? Should she include 1? I see Amanda shaking her head yes. McKenna is shaking her head no. Tyler saying yes.
I think yes.
Yeah, Betty's saying yes too. So Evelyn, if you labeled those as people, right? Like, and I used on mine, I used letters because I was getting confused with the person number and the number of handshakes. So I used letters for my people. So count your number and see if you really did 18 people or if you only have 17 people counted.
So I would do the +1 though too. Okay. I was just confused because I was like, well, there's one person left. And I just like imagine them shaking their own hand. I even had 153 and then I erased it. I kept going back and forth. I just was so unsure of that.
That's funny. Okay, so now 153. Now, who shared in the beginning? Michaela. Michaela shared your answer of 306. Yes? Is that correct? Okay, I think we know Bethel's was a little too high because she did 18 times 18 instead of 18 times 17. But Michaela did 18 times 17. Does anyone see a connection between the number 306 and 153?
That's half of 306.
Oh. So remember we talked about those double counting? Yeah. So if we divide that by 2, if we do 18 times 17 divide by 2, don't we get 153? Yeah. So that strategy works. You just have to remember to rule your double counting. Yes. Tyler and Tristan, I think a lot of you did 17 plus 16 plus 15 plus 14 plus 13, which totally works. A shortcut would have been Michaela's strategy of 18 times 17. You just have to remember to divide by 2. Nice. Was that problem kind of fun? Did you like it? Yeah, you could do a million different ones, you know, like you could rephrase them as high fives. You could do they meet other people at the party, right? Like the context could change, but the problem solving strategy would remain the same. Yeah. Okay, good. I just wanted to make sure we knew how to solve problems still, just in case you thought we were just on arithmetic town. We're not. Okay. So let's talk about integers. What are integers? Why do we use them? When do you ever see them? Let's first talk about what are they? What are they? No one knows what integers are.
Numbers that belong to a set. So it
Ooh,
can
yeah,
be
what set?
or negative.
Say it again, Vanessa. Sorry, I was fixing my headphones.
Are numbers that can belong to a set. So it's on the number line. It can be negative or positive.
All right. So I love that you said negative or positive. The number line worries me a little bit because aren't all numbers on a number line?
Yeah,
Yeah.
very true.
Yeah. So essay put whole numbers, positive or negative. Hannah says whole numbers and their opposites. Brianna says negative or positive. What does whole numbers and their opposites mean? What are whole numbers? Nobody knows. Boy, you guys should be practicing for your oral exam right now. Right? Answer out loud. Practice your vocab. Take it from somebody who gives oral exams all the time. So what's the set of whole numbers?
Isn't it every number, like number besides zero, right? Because you can't do an opposite of zero, correct?
So interesting that you would bring that up. The opposite of zero is just zero because zero is not a signed number, right? Although it's really annoying because I look on my weather app, my son is in Omaha, and they say the temperature is -0, and it drives me up a wall. I know I'm going to have to write weather.com and tell them to fix it, but I don't think they're going to. But whole numbers, there's a set of natural numbers, and then there's the set of whole numbers. Natural numbers start with 1 and continue in the positive direction. Okay. Whole numbers actually do contain 0. Okay, which is we need whole numbers. We need that 0 in order to do addition and subtraction. But the key there is what Hannah was saying, whole numbers and their opposites. And I love how essays like not fractions. I agree with you, not fractions for sure. So their opposites, if I said what's the opposite of 4? You would say?
-4.
There you go. If I said, what's the opposite of -12? You would say +12. Very nice. So we naturally know that when I say opposite, you change the sign, right? So if I say the set of whole numbers and their opposites, that is what integers are. Okay. And can you think in real life when we use integers besides weather, because we definitely use it with weather? Taxes. Yeah, some of us are all too familiar with it relating to money, right? Negative amounts of money, right? When my bank account is overdrawn or how much debt you have. Let's just not go there, right? That's a little depressing. So, and ancient philosophers, especially mathematicians, like in the time of Pythagoras, Aristotle, Plato, all of them who sat around and thought about math all the time, they said there were no negative numbers. They said that was nonsense. You know, they said if you did 4 minus 5, nope, can't do it. Cannot be done. But later, as we developed our society and our intellect, we thought, wait a minute, well, we could have negative numbers because when people are borrowing from each other, this idea of owing, we can have. So we created negative numbers reflecting what we saw in real life. And we just had to make sure that they didn't break any of our already set math rules, right? That they modeled what was really happening. So if you thought negative numbers were made up, you are correct. They are made up, right? But they're very sensible because we see them in everyday life. There it is, whole numbers and their opposites. We talked about that a little bit already. The temperature in Alaska is negative 23 degrees Fahrenheit. The depth of the ocean off the coast of Florida. Now, be careful if you talk about depth of something, because some people say it's negative 575 feet below sea level. You can't say both of those together, right? It's either negative 75 feet relative to sea level, or you would say it's 575 feet below sea level, which would mean it's negative, right? But you don't want to say negative 570 feet below. That would be saying that twice. So don't do that. And again, we're not talking about our bank account balance being negative $300. That's very depressing. Okay. Number lines are really helpful. Vanessa brought up number lines, and they are great with negative values. It is excellent to see them because we need a visual to see this. So Angela lost 4 pounds. So if 0 was her weight, then 1, 2, 3, 4. Here would be negative 4 pounds, right? All right, and we can label all these tick marks, right? Kids sometimes get confused on the direction of the numbers, so be careful. Okay. How about these two? Think about how you would label the tick marks that I provided on these number lines, because each tick mark can't represent one. So Laura spent $60 on her debit card, and Akara snorkeled 40 feet below the surface of the water. So think about those for a minute. Look at my number line. What would you make my tick marks equal to? I'll give you about 30 seconds to think. All right. What would you do the tick marks on this first number line if I want to show negative $60?
You can do 20 for each tick mark.
All right, so we'd say 20, 40, 60, 80, 100. And this is in dollars down here. And so this would be negative 20, negative 40, negative 60, negative 80, negative 100. And I would mark it right there. And you have to be really particular for students and have them attend to precision and label all those tick marks, right? Because you'll be amazed. You think they can count by 20s and then they can't, right? They write 20, 60, and you're like, what just happened? So you have to make sure you're really checking that. And it might just be they made a mistake, but sometimes there really is a wrong idea happening there. Okay, how about on this second one? Same scale?
You can do 20 or 10.
Yeah, you could use 10s if you wanted to. 10, 20, 30, 40, 50. There was no rule, but I will definitely mark this. I will label it right here. This is in feet. This is in dollars, just so I don't have to write the symbol every single time, because then it'll get too crowded in there. So kids get confused with that. Like I said, 40 feet below means negative 40. But again, you don't want to say that twice. You don't want to say negative 40 below. All right. We talked about this a little bit using the word opposite. You were not taught the language of integers and how to speak mathematically when you do negative values. It's really important, and you'll see why it gets so confusing to students and probably maybe even you. So we talked about 4 is the opposite of negative 4. Negative 4 is the opposite of 4. Another useful way of thinking of this is to add another negative sign to the number. So if you look at this down here, if we have this sign, which means take the opposite. So if we read that as take the opposite of positive 4, then we see, oh, that's negative 4. And because you've had teachers who read this part, -4. Yeah, you've heard a teacher say that before. That makes no sense. Okay, it's confusing. Don't say it. If you use the word opposite for that second, that negative sign that's outside of those parentheses, if you read it as the opposite of -4, it makes more sense mathematically. The opposite of -4 becomes +4. Now, you also had some teachers who said, I'm actually multiplying those two negatives together because there's an imaginary 1 here. Did anyone have this teacher that did that? Yeah. Why are you complicating your life? Right? Don't complicate your life. Right? Just read it mathematically and your life will be easier. I'm not saying it's wrong. I'm just saying that, boy, oh boy, let's muddy the waters a little bit. Okay, we don't want to do that. Now, do absolute value and opposite mean the same thing? No. What does absolute value mean?
Isn't it the distance from 0?
I'm so happy you said that, Amanda. Excellent job. Whoever taught you that or wherever you learned that, that's awesome. Because we don't speak in distances using negatives, do we? Like if I was in an actual room with you, I would say, Vanessa's 2 feet from me. And then if I would say, I wouldn't say the wall is -2 feet from me. That doesn't make any sense. I would still say the wall is 2 feet from me. It's just in a different direction. By the way, I saw a whole textbook conversation that used distances marked by negatives. I almost had a heart attack. Yeah, I wrote the publisher that day and said, you are terrifying me. We don't talk about distances and negatives. Yeah, and so that's when my kids call me Karen, right? You're such a Karen, right? And I'm like, no, it's just mathematically specific. Okay, well, when we talk decimals later, then they'll tell you, yeah, I am a Karen. It's okay. It was just once. It was just one time, and I stopped. Okay, so since it's distance, some of you were taught the definition of absolute value is always positive. It's always positive. If we focus on that definition, when we got deeper into algebra, that got muddy. So if we look at that definition that Amanda gave us, where it's a distance, then that makes sense to us, right? And if we use that word opposite when we need to, we can do that. So let's think of this problem. This we would read as the absolute value, because that's what those straight line symbols mean, of -8. Right? That's how we would read that. And this would be the absolute value of, and you could say +8 if you want. And then this is the important one because kids got confused because their teacher defined absolute value as it's always positive. So they wrote the answer was +8. But on this problem, the answer is not +8. The simplified expression is -8. And the reason is because we should read this as the opposite of the absolute value of -8. And this goes back to order of operations, which we did yesterday. These symbols right here act as grouping symbols, right? Or the P in PEMDAS, which I highly recommend against, right? The G in GEMS, so grouping symbols. So do what's inside the grouping symbols first. So take the absolute value of -8, which since it's the distance that -8 is from 0, then it would be +8. Now I do what's outside the grouping symbols, which tells me to take the opposite of it. So take the opposite of +8. And you would get -8. Do you see how that wording, that vocabulary makes a huge difference? You might not think so yet, but I promise you, if you ever tutor a child in algebra, it will come to light very quickly. And you will be very careful with your vocabulary after that. Okay. Another thing to look at is if I wanted to plot +5 on the number line, I would do that. There's my +5. If I want to think of opposites as the same distance from 0, but on the other side, I can think of 0 as my reflection line. This brings in a visual component or a spatial component to understanding. Okay. And a lot of us are very visual learners, right? So if +5 is 5 units above 0, then the opposite of 5 must be -5, and it must be 5 units on the other side of 0. So the opposite of +5 is -5. And if I have a student that's really struggling with the difference between absolute value and opposite, I print number lines on paper and I have them fold them up. They plot 5, they fold it up on that line of reflection, and then they can see through the paper, through the number line, where it would be on the other side. And for some kids, that visual and that hands-on makes a huge difference. Okay. So this is more of the same thing, just another way to look at it. Same thing here, plot -3, 0 is your line of reflection. So the opposite of -3 would be +3. And kids will do things like this so they can see that these distances are the same. But if you give them hands-on tools, it works. It works for all kids, not just gifted kids, not just regular classroom kids, not just disability children, right? It works for all kids. So sometimes we forget. Anyone in here going into special education? A few of you. I'm very excited. Every special education teacher I've met has been an amazing, amazing teacher, but very underutilized in their school. They're very utilized with their special education students, but the strategies that you use with special education students work with all students. And for some reason, sometimes, especially in the past, special education instructors kind of didn't think that they were at the same level as a regular classroom teacher. And I'm here to say, I would think they're even better than a regular classroom teacher because they give us so much more. So whenever I had an aide in my classroom, because I had a special needs student in my room, or if I was struggling with just a student that didn't qualify for special resources, I would go talk to my special education teachers and I would say, can you show me how you teach this concept? Because their ideas are usually very hands-on, very understandable, and they apply to all students. So if you're ever struggling in your own classroom, please, please reach out to those specialists in your schools because they are amazing, right? I just love them. So great job for those of you who are going into that. Here's another one. I don't think we have to do another one. Let's talk about chips. Anyone seen colored chips before? Yeah, they're all over the place, right? They're usually red and yellow. How many have seen them red and yellow in their classrooms? Yeah. Now on the computer, sometimes they're red and black. Okay. And sometimes on paper, they're black. So you can see, the difference. That's so funny, Bethel. Do you have the plastic ones or the foam ones?
Both. The foam ones are a little bit harder, but the plastic ones go right in.
Yeah. So, okay. So I probably have some sitting around here somewhere, but they're little colored chips and you can buy them in foam or you can buy them in plastic. Anyone have a preference? I prefer plastic. You want to know why I prefer plastic? You can't bite them. Yeah, that sounds weird. I teach college and I have bite marks in my foam chips. Yeah, thank you, Karina. Thank you. I'm terrified for that. Yeah. So, weird. And you can draw on the foam ones. Kids love to draw on the foam ones, inappropriate things. So classroom management becomes a nightmare. You have to have a little talk like, I can't get out the colored chips if you're going to use them inappropriately. Now that's a fun conversation to have before you're trying to teach math. Okay, so I prefer plastic, just FYI. In case you're ordering for your classroom, right? The foam ones are probably cheaper. The plastic ones will last longer. I promise you. You'll have to keep buying the foam one unless you suck them up in the vacuum every day like Bethel. So, okay. So, it's hard to visualize negatives, and sometimes the number line doesn't work for everyone. So sometimes we use colored chips. So which ones do you think are positive? Which ones do you think are negative?
The yellow is positive and the red is negative.
Yeah, why?
I think it's just probably just thinking back, like red is kind of like
Color association.
The association with red is always like bad, and with yellow is always kind of like a positive association.
Yeah.
So I guess that's just some subconscious thing that we choose.
You are totally right. You are totally right. And by the way, red's my favorite color. So what does that say about me? Oh, thanks, Karina. You too. So yeah, red has kind of a negative connotation in real life, but if the chips were red and black, it would make sense too for accounting purposes. Yeah, if you're in the red, you're negative, right? When you're in the black, you're making money. So that's why the term Black Friday started, right? Black Friday was when businesses were finally making a profit. So I don't know if any of you are accountants out there or follow accounting kind of things, but that's where those come from, just so you know. So one yellow chip is going to be a positive or a positive one, and one red chip is going to be a negative or a negative one. So if you look at these pictures, I don't want you to think of an addition problem or a subtraction problem. I want you to just think the value of the number that I'm showing you, one singular value. So for example, in A, the value that I'm showing is a positive 5. I could write this, but I don't have to. Is it wrong if I write it? No, it's fine, right? But we assume if I don't have a symbol there that it is positive. This one here, well, B, tell me what B is.
-3.
Yeah, -3. How about C? What number am I showing? Very nice, Hannah. I'm showing -2. And the reason is because when I have a positive chip and a yellow chip, a yellow chip and a red chip next to each other, they have a value of 0. Okay. They are additive inverses of each other. Notice I didn't use a word that starts with a C. I don't like that C word. And we'll talk more about that. Did you watch a video yet about why I don't like that C word? You'll watch a video soon about why that C word is troubling mathematically. Okay. It can be confusing. It can mean more than one thing. So that's why I don't like that C word. Now, science teachers, people who teach math and science in middle school, like I did, often use protons and electrons conversations. And so you say they have an opposite charge. So now their charge is neutral. So they have no charge, right? So that's fine. That's not, again, not using that C word. Okay. How about D? What am I showing there in that picture? +1. Thank you, Kelsey. Excellent. So I'm going to put a virtual manipulative in the chat, except for I lost it. It was here. It's very depressing. I have it on my iPad. Let's find it on my iPad. Look, it's right here on my iPad. That's very lovely. So on my iPad, and this is a great website to bookmark, so I will show it to you. I will put it in the chat right now so you can have it. It's Phoenix College made these. There's a big push for OER at Phoenix College, which I appreciate. So here's all, you can bookmark those virtual manipulatives. That's where those base 10 blocks are, which I just noticed they didn't have cartons on them. So I'm writing them this afternoon to tell them to add cartons, just in case you're wondering. And then if you just want to look at the chips, if you scroll down on that page, you'll find the chips and you can just click on them, and then you just have to click on the actual app but I'll also put that in the chat. So these are the chips. Okay. So you can drag them out like this. They work really nice with my iPad. Love it. I'm still showing you my iPad, right? Okay. And I can put out 0 pairs too on my board as much as I want. Yeah. And then if I put a negative chip on a positive chip, notice they explode because they're gone. Okay. So I can do that. And then I can just count my chips. I can start over. I can do whatever I want with that. So on yours, or even just on a piece of paper, if you don't want to pull it up, I want you guys to show me, and you could just tell me too, how you would show the number +3. So how would I just show +3?
3 yellow chips.
Yeah, 3 yellow chips. 1, 2, 3. Easy peasy. Now, how would I show +3 with more than 3 yellow chips? Think about it. Draw it on a piece of paper. You can be creative, whatever you want. Think about how you would show +3 using more than 3 yellow chips. I'll give you about 10 seconds to think. Evelyn, hold that up again. Are you sure you're showing me +3? Just count your chips. There you go. Thank you. That's perfect. Yes. Good job in the chat. Loving it. So once I have my 3 positive chips out here, I could put as many zeros as I want, and I haven't changed it. And you can imagine that in a real actual classroom, kids would have chips in front of them that they could touch and round, right? And I had kids all the time that would draw me pictures because I would walk up to every student. You know, I don't know why these always snap. I don't like that they snap. I know they're probably supposed to. But I would have kids who made me flowers, who made me little smiley faces. And I had kids who would do this and put them all over. And then I'd walk around to try to check real quick. And then it becomes not a real quick check, which is super fun for me because I love it when the kids are trying to like get one over on me and see if I'm really going to see if they did it right or not. And then of course you always have kids who do something like this. You'll have the kid who is so easy to check because they'll just do this. And you're like, perfect. Thanks. Doesn't matter. We like all the kids in our class. We love the kids that are drawing little flowers with their chips, right? To make sure, hey, if it's keeping them awake in class and keeping them engaged, they're thinking a lot. So that's awesome. What if I wanted you to show me -5 with more than 5 red chips? -5 with more than 5 red chips. Think about how you would do it. I'm going to do essays. As I said, 10 red. 1, 2, 3, 4, 5. Why isn't it going out there? 5, 6, 7, 8, 9, 10. And then 5 yellow. 1, 2, 3, 4, 5. Oh, did you see what it did? That was annoying. Oh my gosh, I hate it. Stop it. Did you see what it was doing? Yeah, so be careful on your iPad. Okay. There we go. So it's fun, but sometimes we don't want them to explode, right? The good news is they don't explode when your kids are just using plastic or foam chips in your class. So you're fine. They won't explode on you. You're good. Yeah, so 6 red, 1 yellow, 10 red, 5 yellow. So you get the idea there, right? This is our solution for COVID town, right? For manipulatives. So is this ideal? Probably not. Is it better than nothing? Definitely. Okay, so you can interact with that, especially when we do addition and subtraction, you might have a problem. The last thing I want to talk about is teachers make things very confusing sometimes. Like even veteran teachers, they do things for a long time. So if I plot two numbers on a number line, I want to fill in these blanks with just one word that makes the sentence true. So if I plot two numbers on a number line, the one that is further, what is larger? Yeah, thanks, Brianna. Thanks, Hannah. The one that is further to the right is bigger. Now, I've seen this in textbooks before. Instead of just having two statements like this, they would have like 4 statements. One would say, if both numbers are positive on a number line, the number that is further to the right is larger. And then they would say, if both numbers if you plot two numbers on the number line that are both negative, the one that is closer to 0 is larger, right? And so they'll make extra rules. We don't need any extra rules, do we? I think we have plenty. So it doesn't matter if both my numbers are positive, if I'm comparing you, or if both my numbers are negative, or if one's negative and one's positive, or if one's 0, right? It doesn't matter. Whichever number is further to the right is bigger. Do you agree? Yeah. So now this is problematic for some people because if we look at this, -1, -2, -3, -4, -5, then what I'm saying is -2 is greater than -4. Is that a true statement? It is. But if I compare their absolute values, is the absolute value of -2 larger than the absolute value of -4? No. So do you see how this can be troubling for some people? Okay, so just be careful and also practice these symbols. Yeah, people really have a hard time with those. This is greater than. This is less than. So the only reason I wrote this statement was to reverse the other one. If you plot two numbers on a number line, the one that is further left is smaller. Yeah? You okay? It's not bad. Okay. The language and notation of integers. This, I'm not making an assignment for you, so don't have a heart attack. You're like, if she gives me another assignment, I'm going to have a heart attack right now. I feel your pain. If I get another assignment to grade, I'm going to have a heart attack right now. So I feel your pain. No worries. But I have a doc that I think you will like, and it's just for practice. You could put it in your notebook. I would highly recommend you try it. If it takes you longer than 5 minutes, you're doing something wrong. So don't do it anymore. This symbol right here, we use that symbol to denote addition, but it can also be written in front of a number to say it's +4. So let's say we're only going to use the word plus when we're doing addition. Yes? If we're doing the operation of addition, we will say plus. Otherwise, we're just going to say positive. This symbol can be very troubling because sometimes we read it as -4, sometimes we read it as the opposite of, and sometimes we use it for subtraction and we say minus. Yeah. Let's all agree we're only going to say minus if it is the operation of subtraction. Okay. That's the only time we're going to call it a minus. So if I just read this, I'm not going to call that a -4 because there's no operation there. I'm going to call that a -4. Okay. So this activity, not the document I wanted to pull up, this activity is just practicing the language of integers. So the first one, you wouldn't write -4, you would write -4, right? And you probably wouldn't say the opposite of 4, right? We're only going to use opposite when we have double signs. So like on the second one, we would say the opposite of -4. The next one, we would say -3 plus 2. Now I can say plus 2, right? But you've had teachers on this second line to say minus a -4, right? You've had teachers say that, minus a -4. There's no minusing going on there. There's no operation happening. Okay? So just look through these and think about, it didn't say solve them, right? It just wants you to write out the words that you want to use. So everybody look on this list right now. Figure out which ones you're allowed to say minus on. Just take a look at them and see which ones you'd be allowed to say minus on. There's many of them. Nice. I'm seeing them in the chat. So it's the one where subtraction is happening. -3 minus -4, and the 1 minus -5, and the -3 minus 5, and the 7 minus 12. This might seem very minor to you, might not important. I'm telling you, it really makes a difference. I promise you. I've seen it in action. It makes a huge difference. Okay, so I hope you feel like we went over things today. You have some of this stuff that you've already had done on the left-hand side. Make sure you're ready for the midterm, whether it's your oral exam you still have left, and everybody has the Canvas portion left. And then, yes, Karina, I see your question in there. I'll make sure I explain. I don't want to keep you guys as long as I always keep you every single day. And I'm going to make sure I put the exit ticket in the chat. The exit ticket will be very nice. So no worries. There's your exit ticket. And then I'll go over the absolute values. No class on Monday, right? No class on Monday. Questions for me? I go over those absolute values. Vanessa, I'm ready. And then
Yeah.
Bethel.
So you emailed me earlier in the week that we changed my oral exam time. I was looking on Canvas. It still says the other time, the time before.
I just didn't want to cancel it. I just didn't want to push it so then somebody else would sign up for it. But yes, you're 1:30.
Yeah. So
1:30 Friday.
So do I just click on that one to me and it'll just be at just that
You
one?
just come to class. Just come to class time. That's where I am.
Okay. Okay. Sweet.
Yep.
Thank you.
Sorry for the confusion. Bethel.
So I just want to, can you help clarify one word on the oral exam?
Maybe. What?
Okay. Number 6, the different categories of problems. Do you just mean like the unknowns, the start unknown, the change, or the
Those would be
result on it?
structures of problems.
Okay.
When I talk categories of problems, let me look at number 6 so I get. Remember the Jamboard activity that you did with equal groups?
Oh.
Those
Okay,
are categories.
Okay,
Yeah.
that makes sense. Okay, that's it. Thank you.
Yep. No worries. Any other questions? I didn't forget about you, Karina, I promise. Do you want me to do it on the language of integers or do you want anywhere? It doesn't matter.
Just to confirm, the Canvas midterm opens tomorrow, and it's open from tomorrow to Sunday or Monday?
Monday.
Open tomorrow to Monday, okay.
Yep.
And we can have just blank sheets of paper, calculator, pencil, and that's about it.
Yep.
Okay.
Okay, Karina, do you want to do it on the language of integers paper or anywhere? Or what do you want?
Just anywhere. I'm just having trouble like picturing how to word it, I guess.
You're having trouble picturing what?
Like exactly how to word it. Like I know
Oh, perfect.
the answer is, but I just don't know exactly how to word it.
All right. So if I read this one, I would just say the absolute value of 7. And some people would say positive 7, but that's fine. Then this one, I would just say the absolute value of negative 7, which both of these answers are still 7. This is the one where we have to start using that word opposite. And usually we use opposite whenever we see two of these symbols together. Okay, because that's where those words get confusing, right? When we start saying minus, minus, or negative, negative, that just gets confusing. So we're going to say the opposite of the absolute value of negative 7. So we're reading it from left to right. So the opposite of the absolute value of negative 7. Does that help?
Yes, thank you.
Yeah, no worries. Anyone else? Questions? Look at me letting everybody out on time. It's a miracle.
I have a question. I don't know if you can answer it or not, but it's in regards to our midterm. For question 8, I think it's 8. Give me a second.
Is it about the standards?
Yeah. So for example, do you want us to show like to give the examples in the way that the teachers use it in like classroom and how the students apply it, or just like
both?
Both? Okay.
Yeah. So what does it mean to the student? What does it mean to the teacher?
Okay. Okay. Thank you.
Yeah, no worries. Kelsey, Sunita, any questions for me? Yay.
No, I just usually stay around to see if anybody.
Yeah, that's a good idea. I would do that too. How about you?
What was that? I'm sorry, I got cut out earlier during class, but I'm gonna rewatch the recording video later.
Yeah, you're okay. Yeah. Kelsey, I was asking if Kelsey thing.
Oh. Right.
I'm not sure if you can answer it.
Okay.
I'm like really struggling on number 5 on the midterm.
Did you use base 10 blocks to try it?
Yeah, kind of. Like I used it, I'm still kind of confused.
All right, let me stop recording.